Today we are working on notes 3.6, more factoring and graphing. So for examples 1 through 3, we want to factor each function completely and find the roots and zeros, and then sketch. Remember, in order to sketch, you need the y-intercept, x-intercepts, and the end behavior. So example 1, this is in what we call standard form. So let's find the end behavior, X to the third is the largest exponent. So this would be odd, because it's to the third power. 1, so positive, so it would be low to high. So that's the end behavior. Okay, first thing. Next, let's find the y-intercept. So x is going to equal 0. So plug in 0, 0, 0, 0. So everything's 0, so you get 0, negative 36. Again, if you plug in 0, that's 0, 0, and 0. So it's negative 36. Okay. So now the last thing I need is the x-intercept. So to find the x-intercept, we're going to let y equal 0. Before we do, though, we need to factor it first. So how do we factor? Well, how many terms are there? There's 4. So I'm going to group the first 2, group the second 2. Looking at the first 2, there's a GCF of x squared. So that would give me an x plus 4. Looking at the second 2, if I take out a minus 9, that would give me an x plus 4. Common factor of x plus 4. Factor that out. I have an x squared minus 9 left. So right now, this is what my equation looks like. They're in black. That's not fully factored because x squared minus 9 is a difference of perfect squares. So I'm going to go one step further. So this would be x plus 4, x plus 3, x minus 3. So now when I set equal to 0, I can actually figure out my x-intercepts, my roots, my zeros. So this would give me negative 4, this is negative 3, and positive 3. If I set x plus 4 equal to 0, I get negative 4. If I set x plus 3 equal to 0, I get negative 3. If I set x minus 3 equal to 0, I get positive 3. So those are my 3 x-intercepts. 1, 2, 3, negative 4, negative 3, and positive 3. So now I have everything I need. My x-intercepts, my y-intercept of 0, negative 36, and my end behavior of low to high. I have everything I need to sketch. Again, all my roots are zeros. Those are negative 4, negative 3, and 3. And that should make sense because it's x cubed. I should get 3 roots, 3 zeros. Remember, whatever the degree is how many roots or zeros you're going to get. Okay, so now sketch. Starts down low, goes to the first dot. Negative 4. X plus 4 only occurs one time, so I pass through. I have to get back to negative 3. X plus 3 occurs one time, so I go through it. Down through negative 36, okay, back to the next point. At 3, that factor of x minus 3 only occurs one time, so I go through, and there's my sketch. Okay, looking at example 2. So again, right off the bat, we're in standard form. So the end behavior, we would look at the 4x cubed. It's going to be odd. It's going to be positive, so it's low to high. Y-intercept, x is going to be 0. So 0, 0, 0. So negative 45. So now the last thing I need are my y-intercepts. My x-intercepts. So I'm going to factor it by grouping, set it equal to 0 to help me figure that out. So group the first two. Group the second two. GCF of 4x squared from the first two gives me an x plus 5. Minus 9 can be factored out, so you get x plus 5 from the second two terms. Notice x plus 5 is a common factor. So then you have 4x squared minus 9. So this is where I'm at. I'm semi-factored because 4x squared minus 9 is actually a difference of perfect squares. So I can go one step further. So x plus 5 is going to be two binomials. So what do you square to get 4? 2. What do you square to x squared? X. What do you square to get 9? 3. And it's plus minus. This part here in blue is fully factored. That's factored form. So now to find my x-intercepts, I'm going to let y equal 0. So now y becomes 0. Then I set each factor equal to 0. So x plus 5 equals 0. 2x plus 3 equals 0. 2x minus 3 equals 0. So you get negative 5. The next two are a little more tricky. So subtract 3, divide by 2, so minus 3 halves, which is negative 1.5, right? Add 3 and positive 3 halves, and 1.5. So now I have everything I need. I have the end behavior. I have the y-intercept. I have my 3 roots, my 3 zeros, my 3 x-intercepts. So I can sketch my graph. So it starts low. I'm going to go through the point negative 5 over to negative 3 halves. Because again, x plus 5 only occurs once. It's going to pass through negative 3 halves down to negative 45, back up to positive 3 halves, and through. Again, each factor only occurs one time. So it passes through all 3 of those. Okay, and then example 3. So again, got the weird notation here next to the purple arrow. So let's subtract first. X to the third plus 3x squared minus a negative 4x minus 12. Remember, I distribute the negative. So 3x squared plus 4x plus 12. All right, you got to distribute the negative. So now, the part there in purple, right, that I'm underlining, that's in standard form. So when you're in standard form, it's easier to find the end behavior in the y-intercept. So this would be x to the third, so odd, positive, so low to high. And I know a lot of these are coming out low to high. They're not always going to be low to high, but again, it's the same concept. You just got to figure out, okay, well, what's the end behavior? I know, again, a lot of them are low to high. That's not always going to be the case. So next, I need the y-intercept. So I'm going to let x equal 0. So 0, 0, 0. So it would be 12, right? And that's the y-intercept. So up here. Okay, so I have the end behavior, I have the y-intercept. So next is the x-intercepts. So now I have to take my equation and get it into factored form. So it's 4 terms, so I'm going to factor by grouping. Group the first two. There's a GCF of x squared. So you'd have x plus 3. Group the second two. You can take out a 4. So you'd have x plus 3. Common factor of x plus 3. Okay. So now some of you are like, oh, x squared plus 4, you can factor that further. No. Yes, they're perfect squares. It's not a difference though. It's an x squared plus 4. So that can't be factored any further. That is fully factored. So to find my y-intercept or my x-intercepts, y is going to be 0. So 0 equals x plus 3. 0 equals x squared plus 4. So negative 3. Now here's the tricky part here with this one. 0 equals x squared plus 4. You're going to get imaginary solutions. So this would be plus or minus 2i. Those are not x-intercepts. An x-intercept is a real number. Those are roots. Those are zeros. So this one actually has 3 roots and zeros because it's a third degree polynomial. It only has one x-intercept because you only have one real number. So negative 3 is the only x-intercept. Okay, so it's going to start low, come here, and go up. So there's your graph. So the roots, the zeros, are negative 3 plus or minus 2i. It only has one x-intercept because you only have one real number. Now, that won't happen too often for our graphs, right? But it is a possibility. And then the last example is a review from earlier in the unit. So we're going to write in factored form the equation. So it says it's a cubic. So remember that would be to the third degree. There's missing a p, so there should be a p there. So you have 1, 2, 3 zeros, 3 roots. So those are your x-intercepts. So p of x equals a. So I'm going to have 3 grouping symbols because I have 3 zeros. So if negative 1 is the 0, then the factor would be x plus 1. If 2 is the 0, then the factor would be x minus 2. If 3 was the 0, then the factor would be x minus 3. And how do I know they're zeros? Well, it says p of negative 1 equals p of 2, which equals p of 3, which equals 0. So when you plug those values in, you get 0. That means it's an x-intercept. So that means it's a 0, it's a root. So now the last thing they do is they give you this point, 1, negative 4. I'm going to use that point to help me solve for a. So negative 4 equals a times 1 plus 1, 1 minus 2, 1 minus 3. So negative 4 equals a times 2 times negative 1 times negative 2. So coming over here, negative 4 equals a times 4. So a equals negative 1. So just replace that a with negative 1, and there you go. The part I'm circling right now is your equation. And it should check out. It's x times x times x, which would give you x to the third. That's a cubic function, and that's what it said it had to be, a cubic polynomial. So there we go. So there's our function. So that was a review from an earlier lesson. So again, all comes back to this entire unit is, can you sketch these functions? Right? The last couple of days we've been practicing being able to factor by grouping to get it into factored form to find the x-intercepts. Make sure you answer your essential question as you write your summary, and then you'll be done with your notes.